All right, sorry if there's sound in the background. I'm doing laundry right now. So this is the second FRQ from the 2016 AB exam. Since it's FRQ 2, that means it's calculator active. So the first thing I'm going to do is plug this into my calculator. So we've got 1 plus 2 sine x squared divided by 2. So first, before we go too far, remember anytime you type sine or cosine in calculus, you should be in radians. So your calculator is probably not in degrees, but just clearing it regularly, double check, that sort of thing. So this says for t is greater than or equal to 0. The reason I like to type this in here is not even that I think that I'm going to need the graph, but if I can make sure that I don't have a typo right here, then I can avoid a typo in the rest of the problem, and I can just keep referring back to y1. So it's going to save me a little bit of time later, and it's going to reassure that I get it right. Okay, so they want to know if the particle is speeding up or slowing down, so that means that we need to know what the velocity is at 4, and we need to know what the acceleration is at 4. And so to find the velocity at 4, I'm going to do alpha trace, so y1 of 4. I can do it on this screen, I could have done it by looking at the table, whatever. So I've got 2.979, which is greater than 0. And then math 8, I'm using y1, plugging in 4. So this is me saying take the derivative of what I have in the y equals screen and evaluate it at 4. Negative 1.164, which is less than 0. And so we're going to say the velocity and acceleration have opposite signs at t equals 4. So the particle is slowing down. All right, part B. Find all the times on the interval from 0 to 3 when the particle changes direction. So that's going to happen when the velocity equals 0 is when I'm just going to do velocity equals 0 because we know, like, if it bounced off 0, then the particle didn't change directions. So velocity equals 0 is when the particle stops or changes directions. We want to make sure that it's switching from positive to negative or negative to positive, so I'm going to include that in a little bit. Here I'm going to go ahead and I'm going to set my window. I'm going to say from 0 to 3, and then I'm going to hit the zoom button, and if you go down to option 0, it lets you fit the screen with that domain from 0 to 3. Now sometimes this works well, sometimes I find that the window they give me is kind of dumb, but this window actually is looking pretty good. So here it's positive, that means that the particle is moving to the right, to the right, to the right. It hits this value for t, and then the particle is moving to the left. So I'm going to go ahead and look for the x-intercept on 0 to 3. 2.707. And I'll say that my reasoning, my justification is that the velocity changes signs. All right, C. Find the position of the particle at t equals 0. So it says the particle is at position x equals 2 when t equals 4. So that means that the position at 4 equals 2. So I'm going to say the position at 0 plus the integral from 0 to 4 gives you the position at 4. So we did not often do problems where we went backwards, where we started at something at 4 and went backwards to 0, but it wasn't uncommon for us to know what the initial position was and then to kind of go this way. And so this is the easiest way that I kind of thought in my brain to do these problems. So if I want to know the position at 0, then I can go ahead and just take this integral and subtract it over. So the position at 0 is the position at 4 minus the integral from 0 to 4. So that's 2 minus the integral from 0 to 4. Hey, get down. Hey, get down. Excuse me. Sorry, my cat was on the counter. All right, so we're going to do 2 minus math 9. We're going from 0 to 4. Again, we're using that function that's plugged into y equals. And so we've got negative 3.815. All right, next we're finding the total distance the particle travels from time t equals 0 to t equals 3. The nice thing about this problem is that it's calculator active. So if you guys remember, just looking from 0 to 3 at the velocity, that gives you the displacement. But if you want the total distance traveled, you can put that in an absolute value sign. If you were doing this problem by hand, then you would have to know what t value you were starting at. You'd have to know all of the t values where the particle changed directions, and then you'd have to know the t value for where it ended, and then you'd have to find all those corresponding y values so that you could actually like tally up the total by hand. But the nice thing about calculator active is you can just do absolute value. So I've got math 9 from 0 to 3. Going to get that absolute value sign in there, and then get my velocity function. .301.